Hello geometry students, today's learning target is to talk about the properties of a rhombus. The plural of a rhombus is rhombi, and a rhombus is a parallelogram, so it gets all the properties. So the opposite sides are parallel. I'm going to mark those parallel. The opposite angles are congruent. I'm going to mark those in blue here. Consecutive angles are still supplementary. But the special property of a rhombus, and I'm going to use this applet here, is the segments, you notice, where the opposite sides are equal. So if you look at this picture, you see 6.22 for all the sides. If I make the rhombus different, all sides are still congruent. So the special property of a rhombus is we have 4 congruent sides. I'm going to mark those in green. So we have 4 congruent sides. Now let's take a look at the diagonals in a rhombus. So because a rhombus is a parallelogram, the diagonals do bisect each other. So I'm going to put these red marks. However, the diagonals are not equal in a rhombus like they are in a rectangle. Let's take a look at a visual. So if I look at this visual, I'm going to add the diagonals. And if you add the diagonals, notice in the middle we have 4 right angles. Even if I were to change the rhombus's shape, notice that we still have 4 right angles. So one property of a rhombus is the diagonals are perpendicular. And I'm going to write that down. So the diagonals are perpendicular. So I'm going to add the right angles in the middle. So let's take a look at another property of a rhombus regarding the diagonals. There is a typo, so I changed the bottom left corner to M instead of N. And I'm going to use this applet again. Not only do we have 90-degree angles where the diagonals intersect, but if you look at angle CAB, we have 22.8, 22.8. Angle up by angle CEB, we have 22.8, 22.8. Likewise, we have 67.2, 67.2, and you can see my cursor hovering, 67.2, 67.2. If I were to change the shape of this rhombus, so if I drag it, notice those angles are still equal. So up at angle C, we have 56.28, 56.28. So it turns out that the diagonals bisect the angle. So I'm going to write that down, that the diagonals bisect the angles. And I'm also going to mark that in my picture. So I'll put 1 tick mark down here by NMQ. I'll put a single tick mark up by NPQ. Then I'm going to add double tick marks up at the top and double tick marks down at the bottom. So let's take a look at these 2 examples. So we have a rhombus, and since this is a rhombus, these 2 segments that I'm highlighting in yellow are congruent. So the equation would be 8x minus 13 is equal to 12x minus 61. I'm going to subtract 8x from both sides. And we'll get negative 13 is equal to 4x minus 61. I'll add 61 to both sides. So 4x is equal to 48. And then I'm going to divide by 4. And x will be equal to 12. Now maybe I want to know the length of NM. If I want to know the length of NM, I would plug 12 in for x, and doing that I'll get 83. Maybe I'll want the length of QM, so I'm just going to check this by plugging 12 in for x in QM. Notice I get 83. And maybe I'll even want the perimeter. So if I want the perimeter, we now know all the sides are 83. So to figure out the perimeter, I could do 4 times 83, which is equal to 332. Now, technically, I would just wanted x in this problem, but on the test I may ask you for NM or the perimeter. Let's take a look at example number 6. Again, I have a typo here. This should be letter M. So, first thing we know is in the middle we have 90-degree angles. So we know that W is 90 degrees. Then the diagonals bisect the angle, so we have 57 degrees down at the bottom. We also have 57 degrees right above it, because that diagonal, I'll highlight it in pink, bisects the angle. Likewise, angle X and angle Y are also 57, as we saw in the property that those angles were congruent. So X is 57, Y is equal to 57. And then the last thing I need is Z, and I'm going to highlight, we have a triangle here. So we know the angles in a triangle add up to 180 degrees. So to find Z, I add 90 plus 57. Doing that, I get 147 degrees. And then to find angle Z, I can subtract 147 from 180, and you'll get 33 degrees. So Z is 33 degrees. So I just scrolled down a little bit, or made the screen a little smaller. I actually did want PQ, so we know that PQ is 83. And as I discussed, the perimeter is 332. Let's take a look at example number 7. In example 7, we have angle PQR is 17x minus 80. That's where the diagonals intersect, so we know all the angles where the diagonals intersect are equal to 90. So the equation would be 17x minus 80 is equal to 90. I'll add 80 to both sides, and we'll get 17x is equal to 170. We'll divide by 17, and x is equal to